Dear students, welcome back to Teleclass Physics, Units and Measurement. In the last class, during my lecture, I did a very dumb calculation. I don't know how I committed something like that in front of you all, and that is there here on the screen. While subtracting 12.4 from 12, I did 12 minus 12.4 as 0.6, and the modulus was written as 0.6 centimeter, and many immediately commented below the video, and many texted me in WhatsApp, and one Alan, he even called me. Okay, thanks for that one, because that actually shows how interested you are and how keenly you are observing all this. Answer should be obviously 0.4, not 0.6. And few got confused, like when the teacher says something like this, there must be something behind what they studied, but there is nothing. That was a mistake from my side. Sorry for that. Answer is it is 12 minus 12.4 must be modulus. It's negative of 0.4, and its modulus should be equal to 0.4. And since these as unit, this answer is 0.4 centimeter. Every calculation after that will be using 0.4, not 0.6. Okay. In fact, this is a message from my class that if I make some mistake somewhere in all my future calculation, there will be lot of mistakes from this one. Okay. We say one error can propagate through different steps of your calculation. So in a way, it's like a demonstration. An error while teaching about errors. Anyway, let's continue from the last class. See, last class we just started the idea about error in a measurement, importance of expressing error in a measurement, and the three different forms in which we will represent error. And we actually studied with the one measured value, one true value, and I gave an assignment like this one. I am so happy that YouTube is now flooded with answers, that too correct answers. Like there were only one or two students who actually committed silly error in this one. It's okay. It happens because this is the beginning of your +1 science learning. What was given is that this is the true value, assuming it is the true value. The measured value is given. You are asked to find what is this AE, absolute error, and RE is the relative error, and P is the percentage error. It was actually easy. Okay. 100 is measured as 98. What was the definition of absolute error? Absolute error is the modulus of difference between the true value and the measured value. I gave you absolute error was the difference between true value and the measured value. Take the modulus. That's what we need to do. How do we get relative error? Relative error is given by absolute error divided by true value. And how do we get percentage error? That is absolute error divided by true value into 100. This is what you have to do. 1, 2, 3. These are the three steps. Okay. So what is the true value? 100 centimeter. What is the measured value? 98 centimeter. So 100 minus 98 will give you 2 centimeter. I think I will go for a different color, black. Okay. So this gives you 2 centimeter. Second case, 20 second minus 18 second, that is 2 seconds. Third one, 1000 kilogram minus 998 kilogram, that is 2 kilogram. This time I must be very careful about subtraction. Okay, I should not go wrong. I can't make errors in errors. Fine. Now see, the absolute error in all the three measured values are equal. Absolute error, same magnitude. In all the three measurements, it's equal. How do we get the relative error? You divide absolute error by the measured value, by the true value. Absolute error by the true value. So here what you have to do is that you need to do 2 centimeter by 100 centimeter. That's it. First case, it is 2 centimeter by 100 centimeter. There is a lot of meaning in each of these steps. Okay, centimeter and centimeter cancel, you will get an answer 1 by 50. I told you 1 in every 50, that is the meaning of it, 1 in every 50. Fine. So this answer is 1 divided by 50. Okay, I'll write here black color, 1 by 50. In the second case, that is 2 by 20, 2 by 20, which gives you 1 by 10. And the third case, that is 2 kilogram by 1000 kilogram, that gives you 1 by 500. See, the absolute values of errors were equal in all the three of them. The amount of error was same, but see, the fraction is not the same. This is 1 unit in every 50 unit. Second one is 1 unit in every 10 unit, and third one in every 500 unit. Now convert this into percentage, because percentage is always easy to understand and compare. Okay, 1 by 50 into 100, that's what we need to do. Multiply this by 100, so 100 by 50 will give you 2%. Second one, 1 by 10 into 100 gives you 10%. And the third one, 1 by 500 into 100, that is 1 by 5, this gives you 0.2%. Now see, absolute error, the magnitude of error in all the three values were equal, but the percentage is not equal. So if you want to know which one is correctly measured, you always look at the which is reliable. Which is reliable in this thing. Of course, this measurement 0.2% is reliable than other two, and the second measurement is not at all reliable. There is a variation of 10%, and this is not at all acceptable. Fine. So that is the answer to your question. Compare your answer with my answer. And I think only few people got confused about this percentage calculation. Few actually wrote it as 2% in all the three cases, because they saw the same thing too here. Maybe they thought this is 2 centimeter, that is 2%, so this is 2 seconds, then that will also become 2%. That's not the case. So you can see the percentage variations are actually different. Okay. So anyway, congrats to everybody who did this immediately and commented in the YouTube. So again you have the definition in your board. What is absolute error? What is, how do we calculate it? Magnitude of the, in examination they will ask you, define absolute error. So what is your answer? You know how to calculate it, but you need to write and study. That's a different thing. See, writing theory examination and writing entrance is different. In entrance, you just need to know the concepts. But in the theory examination, you need to know how to represent this without any mistakes. So the evaluator should understand what you mean. Okay, so the magnitude of the difference between the true value of a quantity and the individual measured value is called the absolute error of that measurement. Absolute error is the modulus. What is the meaning of this vertical bracket? Modulus of true value minus measured value. Today a student asked me, should I take measured, is it okay if I take measured value minus true value? That is also okay, because you are taking modulus. Fine. But it's always good to go with the text, because a teacher will maybe having a habit of giving mark only for this statement. And when the statement is reversed, you need not get the mark. You can't argue. Okay. This is given in the textbook, so just study like that. True value minus measured value modulus. Absolute error in a physical quantity A is denoted by delta A. This is very important. Okay. I'll tell you what it is. Suppose that there is some quantity which you call as A. It can be area. Okay. A. Then how to represent absolute error in this physical quantity? In physics, we use this letter, this is the Greek letter, we call it as delta. This delta is used to represent a change. Okay. So assuming that the variation, the error is the variation in the measurement, we call it as delta A. So A is the physical quantity, delta A is the absolute error. Suppose B is another physical quantity, how to represent absolute error in B, that is given as delta B. Suppose Z is a third physical quantity, how to represent absolute error in that one, it is written as delta C. So delta A, delta B, delta Z, these are the way in which you represent absolute error. And in my example here, the quantity is A. So we represent it as delta A. Okay, that is how you represent this. Fine. Next, how do we calculate absolute error? In the last class, I gave you one true value and one measured value. It was very easy. But what will happen if you have a large number of measured value? That's what we are going to study. When you have large number of measured value, how do we do these calculations? Okay, now see. here a1, a2, an. We have seen this before. When I said about the true value, we saw this a1, a2, a3, etc. Okay. Assume that a is something. This is to understand weight of a laptop. I just remember laptop because the laptop is here. If A is the weight of a laptop, in the first trial, I can measure it as A1. In the second trial, I can measure it as A2. In the third trial, I can measure it as A3, and so on. I can take any number of trials. So I'll get A1, A2, A3, AN, etc. These are the different measured values. What are these? These are measured values. A1, A2, etc. AN are the different measured values of a physical quantity. And in my example, that physical quantity is weight. Whose weight? Of the laptop. This can be anything. It can be length, height, time, anything. Then the errors in the individual measurement values are how to find the error in the individual measurements. I mean the absolute error. By definition, absolute error in A is nothing but absolute error. What was the definition? It was true value minus measured value. What is the meaning of true value? We said that true value is not at all available. So we have a technique. What is the technique? We take the mean of all these values. You know, the true value is the mean value. So we will take a mean value, A mean. What is the meaning of A mean? A mean is the mean of all the measured values from A1 to AN minus, which is a measured value. That is an important point. If you want the absolute error in the first reading, this one, if you want absolute error in the first reading, what you should use? You should say A mean minus A1. What is modulus A mean minus A1? Modulus A mean minus A1. A mean is the true value. So this is actually true value minus measured value. And true value minus measured value is called absolute error. But whose absolute error? Absolute error in the first measurement. Delta A1 is equal to A mean minus A1. That's it. Fine. Now, how do we get the absolute error in the second measurement? And these are actually printed here. Delta A1 modulus A mean minus A1. Delta A2. What is delta A2? It is absolute error in the second measurement is A mean minus A2, and so on. The last value, delta AN, A mean minus AN. So you, as many number of values you have, that many number of different errors you will get. Now, okay, now see this delta A calculated. This delta A calculated, this value, sometimes it can be more, sometimes it can be less. That's why it can be positive in certain cases and negative in certain other cases. But we are taking the absolute values, so all the values will become positive later. So the absolute error can be positive or negative, but the modulus of that one will be always positive. Clear? Now from this, after this, what will you do? Mean absolute error, because you have so many measured values. For each measured value there is one absolute error. You have to take the mean absolute error. Find the mean. So here we have to find two times. Mean must be calculated twice. One, to find the true value, you have to calculate the mean value. Then to find the mean absolute error, what to do? You have different absolute errors now. You have delta A1, then you have delta A2, you have delta A3, and this can be positive or negative. So you take the modulus, then you take the modulus, then take the modulus, then add them. Plus how many are there? There are n numbers. Then you divide it. You want to find the mean value. So what will you divide it with? You will divide it by the total number of terms in that one. So this is the arithmetic mean of all the absolute error is taken as the final or mean absolute error of the value. It is represented as delta A mean. This is the mean of delta A. So we represent it as delta A mean. And that is step here. So delta A1, you take the modulus. So this will, see, if you don't take modulus, what happens? There is a chance of getting cancelled, because one error can be +1, other can be -1. If you add them without taking modulus, you will end up with a 0. That is not the way. You have to take the modulus and add. So we calculated So tell me, what are the calculation we did so far? First thing, you calculate the mean value of the measured mean value. Then you calculate absolute value, absolute error in each value. After that, you find out the mean absolute error. So now you are left with, after calculation, after this calculation, what you will have in your hand? You will have the A mean and you have this delta A mean. A mean and delta A mean. Please comment in the box. What is the meaning of A mean? What is the meaning of delta A mean? Right now, timestamp and comment. A mean and delta A mean. Okay. Fine. Next point. Next point. How do we find out the relative error or the fractional error? See, relative error is also called fractional error because you are taking a fraction. How do we take the relative error and fractional error? Then the relative error is the ratio of, it is a ratio of what? Ratio of the mean absolute error and the mean value. In the last class assignment, there was only one measured value, so there was no meaning of mean value. We were taking absolute error divided by the true value, but here you have to take the mean value. So that's it. Relative error is delta A mean by A mean. I hope by now you know the meaning of delta A mean. So you take the ratio. That's it. Okay. These things are easy to hear and see, but when it comes to the real problems, okay. Now percentage error. By definition, percentage error is nothing but relative error into 100. We already done it, and that's by new definition, new equation, delta A mean by A mean into 100%. This is it. Steps are the same, but the number of quantities are different. Now, without understanding this, you will not go further. I will not take class. You have to study this. What is it? First point. Absolute error is what? It is the modulus of true value and measured value. What is relative error? Absolute error divided by true value. Then percentage error, absolute error by true value into 100. And the last point you should know, absolute error is what? It is relative error into true value. Absolute error is always relative error into true value. That's available from this equation. Absolute error is relative error into true value. Is that okay? If that is okay, now it's time to test this. It is time to test your knowledge. What is given? Is an example, numerical. You will get a lot of numericals like this in your examination. Okay. Here it is a measurement of something. There was a measurement. And in that measurement, what was measured? Diameter of a sphere was measured in different tiles. You have a sphere, you take the measurement and you get 1, 2, 3, 4, 5, 6 different measured values are there. So if I say diameter can be represented as D, then what is the meaning of D1? D1 is the first measured value and that is 1.54. See the unit, that is centimeter. Immediately test the least count of the device. What is the least count of the device? The least count of the device is 0.01 centimeter. Now what is the second measured value? D2, that is given as 1.53 centimeter. There is a reflection problem, so it's difficult for me to see. So if I make a mistake, please see that one. That is 1.44. Then the fourth one is 1.54, fifth one is 1.56 and the sixth one is 1.45. All are centimeter. See, all of them are from the same device because all of them have the same least count. This is applicable for everywhere. Which is the true value? Tell me, how to find true value? How to find true value? You need to find the mean of this thing. So, D mean is the true value. That is the, that is the true value. So, first step is to find the true value of all the measurements. Okay. After that, what is the question now? Calculate. What to calculate? Mean value of the diameter. That's the first step. Mean value. Then absolute error in each measurement. Absolute error in the first measurement. How to find absolute error in the first measurement? You calculate the mean value. From the mean value, subtract this one, take the modulus. Then mean absolute error. You will get how many absolute errors? There will be 6 errors here. You take the mean of all these errors. Then find the relative error. How do we get the relative error? You get the mean error here, divided by the true value, you get the relative error, then multiply by 100, you get the percentage error. And the last point is important. Also express the results in terms of absolute error and percentage error. That's it. Okay. Now let us see. You can try this. I think you better stop the video and calculate this if you are serious. First point, calculate the mean value. This is the calculation for the mean value, and I'll get 1.51. Now one more point. Suppose in any calculation, here I think you'll exactly get it as 1.51. No problem in that. Suppose here the answer was 1.5123 centimeter. This is possible. When you take a ratio, this is possible. But you can't accept this. You know why? Because each of this measurement comes from a device of least count 0.01 centimeter. But if you write an answer like this one, this comes from a device of least count this much, and this will not match. So you can't take this many decimal points in your answer. You need to round this off and remove these and write it as 1.1, same decimal point as the given value. This is important. Fine. We'll learn about this later. So you got the mean value, that is 1. This 1.51 is taken as the true value of the measurement. Fine. After that what? After that, absolute error in each measurement. Delta D1. Delta D1. What is the meaning of delta D1? What is delta D1? It is the absolute error in the first measurement. How do we calculate the one? What is 1.51? It is the mean value minus 1.54. What is 1.54? It is the first measured value. And you take the modulus, you will get 0.03. Similarly, do for all the 6 values. Okay, so certain values will be positive, certain values will be negative, that you can see. See here 1.5, this is a negative value, this one is a positive value, right? No, this is a negative value, this is a positive value, this is a negative value, and so on. But you take only the modulus, so that's why there is no negative sign here. Tell me what is the next step. Now find the mean of all these values. That's here. Mean absolute error. You take each of that one. You can see 0.03. What is 0.03? It is the first absolute error. 0.02 is the second error, and so on. So you take them and 6. Why 6? Because there are 6 terms. So you will get a 0.04. This should also be corrected to 2 decimal places. Suppose you are getting a number with more decimal places, correct it to the required decimal places. I think there is a correction required in that step. How to get the relative error? Relative error by definition is delta D mean by D mean. This should be read as D mean, which is this 0.04 divided by this 1.51. 0.04 by 1.51, so you get it as 0.03. See the step, 0.02649 should be rounded off to 0.03. Get the percentage error. You multiply this by 100, you will get approximately 3%. Okay, so now after all these calculation, what you have a true value. This is a true value. This is the value of the diameter that you are going to trust. Fine. And you have an absolute error 0.03 and a percentage error, your absolute error of 0.04 and a percentage error of 3%. And there is something incomplete here. This will have a unit. This has a unit of centimeter, but this one and this one has no unit. Okay. So now what? They ask you to present the value, report this value. Now we can report it. Diameter reported with the absolute error. What is diameter reported with absolute error? The diameter is 1.51 centimeter plus or minus 0.04 centimeter. That means the variation is 0.04. And what does it mean? It means that diameter has a range between 1.51 minus 0.04 to 1.51 plus 0.04. And that gives you 1.47 centimeter to 1.55. This is the range into which you can trust this value. Okay, if you report it with a percentage error, it's 1.51 plus or minus 3%. That means the actual value can be 3% less or 3% more. That is the final answer. Okay. Anyway, once more I will revise this question. I'll revise this question. The question was like this one. There was an experiment, 6 different measured values of a diameter were given. You needed to calculate this many parameters. Then first thing, we calculated the true value by taking the mean of that one. Then using that mean and subtracting each measured value, calculated absolute error in each measurement. Then you calculated the mean value of the absolute error. Using that mean value, you calculated the relative error. From the relative error, you calculated the percentage error, and using this percentage error and absolute error, there are two ways of representing this. These are the two ways. Normally, we will not use the relative error representation. We use only absolute error because it's easy to understand. And percentage is also easy to understand. So this is how you do this calculation. And you can expect similar questions in the future, in the examinations. Okay. Now, പറഞ്ഞു തീർന്നില്ല വന്നല്ലോ മനമാല. There is a simple pendulum with different periods. The period of oscillation of a simple pendulum in the experiment is recorded as how many values? 1, 2, 3, 4, 5 different values, exactly like the previous one. Find the average absolute error and express time period with proper error limits. You need to find average absolute error, average means mean, and express the time period with the proper limits. How do we represent the time period with the proper limit? I'll tell you what to do. Finally, you need to get a true value of time period plus or minus absolute error in time period. This is what you want to do. Okay. Now, I am giving you this as an assignment. Next class I will discuss this, or next class I will give you the solution. You try this. Then we will see how much you have understood. You try the first one clearly, then go to the second one. So, answer will come in the next class. I hope you understood that one. Do the second question, from that you will get more knowledge. Now, during our calculation, we saw that the final value is always written as A plus or minus delta A. And the meaning of A plus or minus delta A explained in the previous question as A minus delta A to A plus delta A. Now, my point is this, is it possible to write it A minus or plus delta A? Instead of plus and minus, can you reverse it minus and plus? Obviously, yes. This one also represents the same idea that it varies from A minus delta A to A plus delta A. So, whether you write it as A plus or minus delta A or A minus or plus delta A, it has the same meaning. Later we will use this. Okay, that's what I wrote here. Now, today I am finishing my class with this question. This question. Answer it. See you in the next class.